I'm Dr. Binu. In digital signal processing subject, the second topic in the fifth unit is sampling rate conversion by a rational factor. Sampling rate conversion by a rational factor is the process of changing the sampling frequency of a discrete time signal by a ratio of L by M, where L is equal to interpolation factor, nothing but upsampling factor. M is the decimation factor, also called downsampling factor. This method is normally used in multi-rate signal processing system to convert a signal from one sampling rate to another when the ratio between them is a rational factor. Sampling rate conversion by a rational factor L by M is an important technique in multi-rate system that allows efficient transformation of signals between different sampling frequencies using interpolation and decimation process. F nu is equal to L by M Fn. Fn is the original sampling frequency, Fn nu is the new sampling frequency. Steps in sampling rate conversion. First, interpolation by L. Insert L minus 1 zeros between successive samples. Pass the signal through a low pass filter to remove spectral images. Second step, decimation by M. Pass the signal through an anti-aliasing low pass filter. Keep every nth sample and discard the rest. Adaptive filter. Adaptive filters are digital filters whose filter coefficients automatically adjust according to the input signal and desired response. Unlike fixed filters, adaptive filters can change their characteristics in real time to minimize the errors between the desired signal and the filter output. Adaptive filters are widely used in digital signal processing. It is a self-adjusting system that modifies its filter coefficients using an adaptive algorithm to minimize the error between the desired signal and the filter output. The basic structure of an adaptive filter. It consists of input signal X of n, adaptive filter, desired signal D of n, error signal E of n, and adaptive algorithm. The error equation E of n is equal to desired signal minus filter output. The basic structure of an adaptive filter is represented in a block diagram representation. Common adaptive algorithms are least mean square algorithm. The process of adaptive filter is represented as a flow diagram. The another adaptive algorithm is normalized LMS algorithm, recursive least squares algorithm. Applications of adaptive filters. Adaptive filters are applied in noise cancellation, echo cancellation in communication system, system identification, channel equalization, speech signal processing, and biomedical signal processing. Advantages of self-adjusting filters are that is adaptive filters are automatically adjust to signal changes, works well in an unknown environment, improves signal quality. But adaptive filters are having some drawbacks also. Some of them are computational complexity, especially if you are using RLS algorithm. Convergence depends on step size, stability issues if parameters are not chosen properly. Applications of adaptive filters to equalization. Channel equalization is widely used to remove distortion introduced during signal transmission. Concept of equalization. Equalization is the process of reversing the distortion caused by a communication channel so that received signal closely resembles the transmitted signal. Distortions in channel include amplitude distortion, phase distortion, interceptual interferences. Role of adaptive filters in equalization, which update the filter coefficients automatically. The working principles are: the transmitted signal passes through a channel. The channel introduces distortion and noise. The adaptive filter estimates the inverse response of a channel. Filter coefficients are updated to minimize the error. The output becomes closer to the original transmitted signal. The block diagram for the adaptive equalizer is represented in simple blocks. Types of adaptive equalizers are linear equalizer, decision feedback equalizer and blind equalizer. Applications are wireless communication system, digital television broadcasting, mobile communication, satellite communication, high-speed data transmission, modems and DSL systems. Advantages: automatically adapts to time varying, reduces ISI, improves signal quality and reliability, suitable for real-time communication systems. Adaptive filters are used in channel equalization to remove transmission distortion. It compensates for amplitude and phase distortion and ISI. The filter coefficients are updated using adaptive algorithms, which includes linear equalizer, decision feedback equalizer, and blind equalizer, normally used in wireless, satellite, and digital communication systems.